Okay, so let's do a quick recap. ER models. Is it an attribute? Is it an entity? Is it a relationship? Okay, so we have entity, attribute, relationship, and relationship attributes. So let's talk about a database for publishing for books. So what is an entity for books? A book. Is an ISBN an entity or an attribute? Okay, so the rule is that you can say, okay, ISBN. ISBN is an entity, what other attributes does it have? Right? It doesn't seem to have any other attributes, right? So ISBN is not really interesting enough to be an entity. Whereas a book is an entity because you can think about attributes for it, right? So what are attributes for books? You can have author. Okay, we'll talk about that. So you can have author. You can have name, title. What else can you have? Cover picture. I'm only hearing some of what you're saying. Okay. Publisher. Condition, if it is actually for like used books. What else can it have? Edition, ISBN. Basically, an entity should have, multiple attributes. Every entity should have a key, and the key really defines what kind of an entity is it. So what is the key for a book? All right, so if the ISBN is a key, then you really don't want to have the condition because that's for a specific copy of a book, not the book itself, right? So the key defines what it is. So let's say ISBN is the key, and I'm going to get rid of this because maybe I need to have something else for a book. The second question you have to ask is this entity in third normal form, right? So every attribute that you list here should be a single valued attribute, meaning that a book should not have multiple titles. Does a book have multiple titles? So think of that ISBN should imply everything. Given a book ISBN, there is a specific title, specific edition. Is there a specific author? No, authors, there are multiple authors, right? So most likely I don't want to have author as an attribute, right? Does it have a single publisher? Yes, right? Okay, so publisher is a single one. So now you can say, okay, author. Is author an entity? Is it important enough to be an entity? Can you give up some examples for authors? What do we have for authors? So let's say author is an entity. So it means that it should have some other attributes such as first name, last name, maybe a URL, maybe a biography. Okay. So if you can come up with multiple attributes, it's interesting enough to be an entity, right? So if there are things that are just one attribute, we will think about where they belong. So, and what is a key for an author? The URL should probably be unique if you're going by Amazon thing. And then there are other things, like for example, the publisher. The publisher itself may or may not be an entity, right? Can you come up with attributes for a publisher? Right, so the publisher has a name, address, the year book is published, that belongs to the book, right? Right. No, this is good. So basically you have to keep going back and forth and see. Let's say publisher has a URL also, things like this, right? And let's say the publisher name is actually you. right? So basically, you are continuously shuffling some attributes. You find that they are important enough that you promote them to an entity. Some attributes you know are not part of the entity because it is actually multi-valued, that for a given book there are multiple ones. The thing that we really want to make sure is that each entity is in Boyce code normal form, or in the least in third normal form, or BCNF, if possible. Meaning that the key of the entity should imply everything else. Then you talk about, and then we had this graph that we can draw this as basically boxes for entities. Like book, author, and publisher. And then you have attributes as this. So I had ISBN, title, I'm going to put only a few of them. Edition, year. Author has a URL, first name, last name, and bio. And publisher has a name, address, and URL. And so in here, for example, I had that books have a publisher. Books have a single publisher, right? We said that books have a single publisher, but we have decided that publisher is actually another entity, so I am not going to list it as an attribute anymore. So all my attributes for the entity should be about that entity alone and nothing else. So they should not really go and refer something else, right? So any attribute that is about a different entity, I'm going to also get rid of, because I'm going to represent those as relationships, right? So the relationships basically are things that are not about one entity or the other, but the relationship between them, right? Books have authors, books have publishers. That has to do with basically the relationship between different ones. So we can then draw those using the diamonds. Like this. Okay, like this. So entities are in third normal form, if possible in Boyce code. The relationships have cardinality. You have to ask the question about the cardinality of participation between the two entities. So does a book have multiple authors? Yes. Can an author be in multiple books? Okay. So many to many. So if there is many, I don't put an arrow or anything like that. So let's look at this. Does book have a publisher? Only one? Generally, yes. Okay. Let's say yes. I agree that maybe it's not true, but I want to put an arrow somewhere. Okay. So does book have to have a publisher? I'm going to say yes, okay? But in fact, you can say it's self-published as a publisher. Are you your own publishing entity? It's, there's kind of interesting questions. So if you say that each book has one publisher, you can put an arrow. That means that each book has at least one, but it can also have 0. If you want to say that the book has exactly one publisher, that the publisher is required, you put a rounded arrow here, which is very hard to produce in in PDF form, but it's easy to write down. And can a publisher publish multiple books? Right? So then we had, for example, the books that we wanted to maybe sell used books. Used books basically have additional information such as condition and what else? I guess just the condition. But can a book have multiple book copies? right? If you're going to sell different copies of the same book, you need to somehow put like a little identifier on them, 1, 2, 3, 4, right? And then you can basically represent that as a new entity. So you can say something like book copy, right? And I don't have a very good idea of what my book copy identifier would be. In this case, I invent an ID. If there's a natural key, for real life objects, if there's a natural key, it's better to use that, because this way, if there is a data entry error, you can see it. But for book copy, there isn't. And then you can have condition, okay? So this is a specific copy of a book. So what relationship do I need to have here? Relationship is between book copies are for books, right? Copy of. Okay. So for each book copy, does there have to be a book? Yes, right? You have to know. So for each book copy, there is one and only one book, but for a book, there can be many copies. Okay? Maybe you can even have, suggested price for the copy. And you can also have the listing price for the book. Right? Somebody said price, I'm sure. Right? So the implication is that if you have this, idea, so each book copy, you are giving them as random IDs. So you are basically telling the book IDs, can be any arbitrary number. If you wanted to really list your book IDs as 1, 2, 3 of this book, 1, 2, 3 of that book, that ID would not be unique, right? So in that case, we have to use something slightly different. And then, let's say authors publish books, and in the book, you have a listing order for the author, right? There's the first author, second author, third author. So you can be first author in one book and second author in another book. So I decide to store an attribute that has the list order of the book. Where would that attribute belong? Is the property of the author that there's a list order? You have a list order in a book, right? And the book has a list order for each author. So it is not a property of the book or the author, because either way, the and relation will not be BCNF, because the book may have multiple orders for different authors, and the author may have multiple orders for different books. So those I'm going to put here as listing order as an attribute. So basically this is the general idea, that you have to continuously decide and refine your model. But as you do this, you will find lots of things that are kind of questionable. One of the questions that often comes is, does my relationship connect 2 entities or 3 entities? So my general rule is that 95% or 99% of your relationships will connect 2 entities. There are cases where it is exactly 3 entities, but you have to kind of ask yourself if this is the case. So for example, let's look at this. So you have book has an author and book has a publisher. Is it the case that I can write the same thing as that? I'm going to just put the boxes here. So I have book, author, and publisher. Okay. I could have represented this one too. Does that work? So given a book and a specific author, how many publishers are there? 1. Okay. Given a book and a publisher, how many authors? Many. and given an author and a publisher, that could be many books. So ultimately, in the face of it, it looks like I can do this, but the question is, does that make sense? Okay? You're saying that these three things are coupled. That a person, an author for a book has a publisher. Is it possible that a different author for the same book has a different publisher? Is it possible that, Sibel wrote, Trust for Springer, and then who else? Let's say Jen also wrote the same book, but with a different publisher, Morgan Kaufman. Is it possible? It makes no sense, right? The publisher of the book has nothing to do with me. The publisher of the book is about the book, right? So in fact, if you think about it, this makes no sense. It's actually the book implies the publisher, right? This is like how we think about the functional dependencies. Given the book, I can tell you who the publisher is. Each book has a single publisher. The publisher has nothing to do with the book, with the author, right? It is not the case that book and author imply publisher. Because of that, this doesn't make sense, right? Because here, the publisher doesn't depend on the other two things. It only depends on the book. So this is actually incorrect, that I do not need this. I actually need these two separate relationships, right? Books have authors and books have publishers, right? They're separate things. Even though you may be representing maybe something similar looking, logically it's incorrect because you are saying these three things are coupled in real life and it's not. Okay? So let's try a different example. This time I'm going to have a student, faculty, and major. Okay. So I'm going to say, so this is like, example of this is like, comp sci, ITWS, the example of these are obvious. So I'm going to say that student is advised by, student has a faculty advisor for a specific major, right? So let's try to write down these ideas. So a student for a specific major has one faculty, okay? And they really should have a faculty, it would be nice. A faculty for a specific major can have many students, and a faculty for a specific student can advise for maybe multiple majors, right? So there are majors like game design and cognitive science. So, like Bram probably advises both of them. So it is possible. But if it is not possible in your model, then we will talk about that, okay? So what this one is telling me is this. This is telling me that given student and major, I have a faculty advisor. This is telling me that these three are linked because I need two things to apply the other one, right? So because of that, it makes sense that I have these three together. Let's say that instead of using the three-way relation here, I use three two-way relations. So I have, let's say, try to represent the same thing as follows. So faculty advises student, faculty advises for a major, and student is in a major, right? So if I represented that as three two-way relations, this is what it would be. And then we can write the same thing. So we can say that student can have multiple advisors, and faculty can have multiple students. Student can be in multiple majors. Majors can have multiple students. Faculty can advise multiple majors, and a major can have multiple faculty, right? So basically what I did is, for all intents and purposes, I had kind of a relation with student, major, and faculty, right? So previously my relationship here kind of implied student, major, and faculty in a single relation. And I had the case that student and major implies faculty. What I did here is I decomposed that relation into three two-way relations of student and faculty, student and major, and faculty and major. Okay? So if you take that relation and decompose it as such, you can find that if you use the Chase algorithm, this is not lossless. You cannot join this to get the original relation. Okay? In the course notes, you can't see that, but you can intuitively see, right? So I can find that the student has an advisor, and I can find that student is in multiple majors, and I can find that faculty is advising that major, but I cannot tell if that faculty is the advisor of that specific student for a major, right? There's just no way to recover that information once you split it like that. So it's a challenge that you have to continuously ask yourself, where you have relations where all the three are actually related or not. Okay? Sometimes you have a functional dependency like that. Sometimes it's multi-way all three directions, right? So for example, an artist can be featured in different tracks of an album, right? So if you had something like this, okay, let's see. So if you had artist, album, track, I'm not so sure actually if that works. Okay. So an artist for a single track, I guess it depends on what this one is, so I'm going to abandon that, but we can get back to that one in a second. Okay. So this was one of our basic criteria, right? So we said that entities should have multiple attributes, and entities should be in third normal form. Things that are about other entities, attributes that are about other entities should be relationships. Relationships can have attributes, but those attributes should be about the relationship alone, not about one entity or the other. And you can have many of those. There are other things that we have not yet figured out how to do. One of the things is, what about if you have lots of entities, but they are all very close to each other? So you can say, well, if I have a database for a university, there are all sorts of entities, things like you have students, you have faculty, you have staff. Are these the same entity or different entities? So, well, the first question I ask is, what are the attributes for students, faculty, and staff? So, for students, you have, let's say, a RIN, name, major, and year. What things do you have for faculty? Faculty also have a RIN, name. What attributes do faculty have that students don't have? Department that they work in. I mean, that will be a relationship, but I'm going to just put it in. That's true. Not wrong. Salary, and maybe that year that they have started. They also store our home numbers, but yours too, right? Year started work. We have rank, assistant, associate, don't care. And then staff. Now you clearly have RIN and name. What other things do staff have? Say it again? Staff is not considered faculty. Staff have also a title, but faculty and staff have kind of slightly different rules and regulations. What else? Office, that's true. Faculty also have office. It's kind of very confusing, like School of Science dean is a faculty, whereas the first year dean is actually staff. One is an academic position, the other one is not, even though they both say dean. It's very complicated. All right. So when you have this idea, you have to decide, do I have a single entity or do I have multiple entities, right? So clearly, all these entities have some common attributes and some specialized attributes. Right? So you can decide to put all of that in a single entity, but what you will end up with is lots of attributes don't really apply to that entity. Right? So if you find yourself kind of undecisive, you can actually represent this as a hierarchy of different classes. So like you have hierarchies in programming languages, you can have a hierarchy, but this is a hierarchy of information, of type. So it's a little different than like a hierarchy that you are used to. So you can say that I have this general class of just people, right? You hope that faculty and students are all people, right? So I'm going to call everybody people. So I can say that we have basically this thing called people, and all the people in my database have a RIN, a name, and not everybody has an office. Everybody has an email though, right? For sure that we should have an email for everybody. Right? And most likely you probably want to know their home address. They certainly want to know my home address. Right? So this is all the things that is common to all of these entities. Right? Then you can say, well, given a people relation entity, you have subcategories of this. So you have faculty, student, and staff. And you can say that this is a subcategory of this by this special relationship called is-a. Right? When you put a category like this, the implication is very specific. It says that any entity here will inherit from the student class. So what it will inherit is the attribute. So all staff will have RIN, name, email, and address. But in addition, they will also have title and office, faculty will have rank and office, and the student will have major and year. And you can, for example, have things like, department as an entity, and you can say that faculty works in department, right? And staff works in department, but not the student. And remember that this is not a three-way relationship. It's not that faculty and staff work in departments. separate things. They have the same ultimate relationship, but they are kind of roughly the same. Yes?
For office student and ranking office.
Yeah, I think that I messed up. This is supposed to be student. This is supposed to be student. Supposed to be faculty, right? So this should be major and year, and this should be rank and office. I wrote that wrong. This is still one of my better efforts. Like the time last week I showed up for a meeting a week early. That was not the best of. All right. So basically, the point of hierarchies is that you basically are putting kind of higher resolution, but you have design decisions to make. You can say, if two entities look very similar, they have roughly the same entities, maybe I can merge them, right? So from a programming perspective, having lots of these specialized entities will mean I have to write more specialized code. But if you mix things that are very different than each other, then you're going to basically have to have all these different flags to remember that if it's a student it has this attribute, if it is a faculty, then it has these attributes, it will make it complex. So the rule is that merge things that are very similar, but keep things that are different enough in separate entities. And as you practice this more and more, it will become more obvious. So there are two questions we need to ask. Okay? Whenever you have a hierarchy, you have to ask a question. So, are there people in my database that are not faculty, student, or staff? Do everybody have to be in one of these three classes? Are there any other people in the database? Can somebody be a person but not be faculty, student, or staff in my database? So it depends on how the database is, yes. But we don't store alumni in our database, I think. But that could be a good question, right? So if alumni are not stored there, right? Because they even get rid of your email, I'm sorry to say. Yeah. But yeah, so the question you have to ask is it covering or not? So the idea is that if faculty union student union staff is equal to people, then this means it is covering, that these three entities cover all the people, right? The other question that you have to ask yourself is, can somebody be faculty and student at the same time? Can somebody be student and staff at the same time? You can have, I don't know if you officially are staff, but you can also be a staff taking classes, right? So in that case, you have to be registered as student because you can only register for classes if you're a student. So in fact, these categories are not necessarily disjoint, right? That's going to matter when we actually take this and convert to relational data model. So you have to ask, are these disjoint? So for example, how about faculty intersection student? Is it empty, right? So you have to understand whether it's disjoint or not. Okay. So if you find things that are very similar in general, put them in a single entity. Otherwise, put them apart. So that's kind of the general rule. So let's do one last thing, then we will be at a good stopping point. We had the one idea that you had books and you had book copies. So do you want to number your copies, the copies of the books, 1, 2, 3, 4, or do you want to number them any random number? So let's say I will number them 1, 2, 3, 4, right? So if I say my book copy is numbered 1, 2, 3, 4, right? So number is 1, 2, 3, 4. The simple thing in this case is that then I can quickly find, what numbers, how many of these do I have, and how many did I have, what did I sell. It may or may not be. Okay? Or I can have a similar one where I have this thing called an album that comes in this round thing that, like it's shiny on one side, you put it in some machine. Have you ever seen those things? Yeah? Like they actually have in multiple songs in a single disc that they call that an album, which apparently people still buy. Let's give it an ID. And an album has what we call tracks. Okay. So how do you number the tracks in an album? Do you give them random IDs or do you call them track 1, track 2, track 3? All right, are you with me so far? All right. I understand that, this is an archaic notion, but we're going to do that. All right. Albums, combinations of songs that have tracks. So the point is that does the ID of a track unique to all the albums, that there's only one track one in all of the database? No. So the idea is that, ID is unique for a specific album, right? There's a track, only one track one in one album, right? But different albums will also have track one. So indeed, that this key is not unique for the whole database, but it's only unique for the album that it depends on. We are going to represent that as a special type of entity called a weak entity. Okay. And I'm going to draw it like this. So whenever you have a weak entity like this, right, that just means that the key for this entity is not unique in the database. But it is unique with respect to some strong entity that it depends on. And I'm going to represent that relationship as also a double diamond. Good luck trying to do those in PowerPoint. And let's call this is in. Okay. So each track is in exactly one album. It actually depends on the existence of an album for there to be a track. And each album has multiple tracks. Okay? And that track ID is not unique, but album ID and track ID are unique together in the database. Right? So this is this notion of weak entity. As soon as you see weak entity, now suddenly the whole world becomes a weak entity, right? So don't use weak entities for everything. Weak entities are for very special things. Okay? This is one example where you know that you want to give it some identifier, but the identifier has an internal meaning, but it is not unique in the whole database. So it is unique in the relationship to one or more entities. So it's possible that the weak entity depends on multiple entities, so you can represent that as a relationship, or a single one. And always, since it depends on another entity, you have this relationship that for each track that has to be an album, right? It always has to be not an arrow, but a rounded arrow. But there's a very good reason to have weak entities. It's because of those multi-valued attributes that we have been disregarding up until now, right? So we basically had student had an ID, name, email, But let's say that the student actually has multiple phones, right? So multiple phones, I cannot put it as an attribute because if I put phone here, since now a student can have multiple phones, this will not be in voice code anymore, right? Everything has to imply. So it cannot be an attribute. So it has to be an entity. But it is possible that you may store the same phone number for multiple students, right? Okay, so that's a good example of a weak entity. And the weak entities sometimes have very little attributes, right? They don't have many attributes. So I can say, well, you know, as you have the phone number and maybe type, like you have a cell phone and a home phone. Like this. Students also have hobbies, right? Let's just keep it hobbies. So students have hobbies. Now, should I just add here the hobby as an attribute? Does the hobby have anything to do with the phone? It's like the stupid example I give, but you know, you're with me. So what I'm trying to show is that this is kind of forcing you to think, to make your relations in fourth normal form. You have another multi-valued attribute, but has nothing to do with the phone, then I'm going to put a separate one right here. And I'm going to call hobby name. Right? These things that are multi-valued, I put in different entities, it kind of automatically starts to become a fourth normal form, just the mental effort is forcing me to do that. Yes?
So, can you explain why hobby
So, because, okay, so this is actually an interesting question. Now, we convert this to relational model, right? You will see that if I had a strong entity, it will imply something different, right? So the question was very good. Why is hobby a weak entity but not a strong entity, right? So you can actually store all the hobbies in a relation and then say that I have those hobbies, right? It does make sense. Whereas the phone number, you have to distinguish who the person is, right? So both are possible, and I am going to allow this. I'm going to have hobby 2. Okay. Now this one is going to be many to many, right? So the student can have many of hobbies, and a hobby can be many students, right? So this is exactly the reason actually why it's kind of not a great idea to always have weak entities. Because it's like everything starts to look weak, and everything weak can also be considered strong. And a lot of the weak entities, you can just give it a random ID and make it a strong entity. Well, what will happen is when we go through the exercise, this will create one extra relation that we ultimately decide whether we need or not. Okay? And whereas that one will not. But there's reasons to have that one or this one. So I'm going to keep both of these, and then when we convert this to relational model, we can discuss. So from my perspective, both are correct for different reasons. So it will depend on what your application is. Okay? If you have an application where you have totally free text for hobby, and you don't care to kind of recognize that you have hobby snowboarding, and mine hobby is snowboard, and they're not the same, right? If it's like totally free text, then you are above that. If you care, you have a control vocabulary of what you want, you are here, right? So generally, this model is kind of telling you, I will list everything that you need, then you refer to it. Whereas the other one is kind of enter whatever you want. But, I will keep both. Both are fine, right? But that one is more likely to be a weak entity. We're okay with that one? So generally, don't see the world as all a weak entity, right? Generally, I recommend use weak entities mostly for multi-valued attributes. But if you are in doubt, make it strong entity. I will never take points off for that. Okay? And generally, you generally create like crazy weak entities, so that's why I generally tell you not to do that. Try not to create too many hierarchies. Just first stick to entities and relationships. That's all I want to see in the quiz. Okay? If you really want, you can put weak entities, but I really don't want you to do all of this in the quiz necessarily. Yes?
For the body has that for the weekend has that arrow pointing to student. So that means that the student has only one hobby.
No. Each hobby entity is for a specific student. But since for weak entity name is not unique, I can still list the same hobby for different students, right? So I can still have, so what this will imply is that this will be basically this will end up being a new relation where you have student ID and hobby name together the key. So because of that, a student can have many hobbies and a hobby can have many students, right? But for each specific instance of the weak entity, there is a specific student. Okay? In the same way, for each student, you can have multiple phone numbers, right? But that phone number can also be multiple students. So generally, since the phone number alone is not unique, phone number plus student ID is unique, right? Now this one kind of implies a similar thing, right? Because you have student and hobby is many to many, so a student can have many hobbies, right? But this kind of tells you, is in addition to that, you also have to store all the hobbies in a separate relation because of semantics. Okay? Since we haven't really talked about how to convert that to a relational data model, kind of little subtle point. Yes?
And also, so what happens if a student handwriting does not have a hobby? Then
That's okay. It's not required. Then you will have no couples in that relation.
and
right?
that diagram will work.
That still works. But if you have a, you can't have more than one. So it doesn't require that you have a, right? You see, we can things are confusing. All right.
That was actually my question, but a follow-up. So off of the weak entity, let's say you had for like phone, you have phone number and type. Does it have to have both the type and phone number, or does like off the type?
No, because basically it says that for each phone that I store, for each phone number I store, I have to have a student's ID. Together they will be unique, right? And for a student's ID and a phone number, there is a type, right? So phone number and student implies the type. Yes.
These are kind of general questions. I know there's a little but use student email. I never see it.
Yes, you can. Unless I told you that it's not unique, right? You can assume so. I mean, there's, you cannot really go through all possible things. Yes.
Just to clarify, the rounded arrow from the hobby to the student or from the phone to the student means that you are required to have a connection to the student from the hobby.
For each weak entity instance for hobby, you have to have a student, right? And it kind of, that becomes more confusing. This one is maybe easier to parse first, right? So for each track, if you're going to store track 1, you have to have an album, right? Since you can have multiple track 1 album ID together is unique. In the same sense, if you're going to store phone number, 8047, you have to say for which faculty, right? So together they are unique. When you convert this, you have to get a relation that has phone number and student ID. And the other one for a hobby, that's really debatable. So that's good. We will leave that and we will convert that to a relational data model. Questions? All right, so I have a 20-minute quiz. You are going to start the quiz, and it will end in 20 minutes. Do your best and see how far.